Hi there, future scientists and math wizards. Welcome to Smile Road. I'm Sir M, and I created this channel just for you, senior high school students looking to make science and math easier, clearer, and yes, even more fun. On Smile Road, we explore exciting lessons in general science, solve real life problems in general mathematics, and learn how these subjects connect to the world around us, from floating boats to your monthly budget. Each meeting, I'll guide you through lessons using simple explanations, real life examples, and even a few challenges to keep your brain sharp. Whether you're reviewing for exams, catching up on class topics, or just curious about how the world works, you're in the right place. Don't forget to hit that like, subscribe, and notification bell so you won't miss any of our learning adventures here on Smile Road. So, are you ready to start this journey with me? Let's walk the road of knowledge with a smile. So, lesson 63 is about understanding innovations in sound amplifiers related to sound and light. Sound is a form of energy that travels in waves, and in many situations, we need to make it louder so it can reach a bigger audience or be heard more clearly. This is where sound amplifiers come in. An amplifier increases the amplitude, the strength of a sound signal without changing its original quality. Amplifiers are used in public speaking systems, concerts, movie theaters, televisions, mobile phones, and hearing aids. Over the years, amplifiers have evolved from large heat producing machines to compact, highly efficient devices. These changes were made possible by innovations in electronics, materials, and integration with light-based communication technologies. How amplifiers work. At the basic level, an amplifier takes a weak sound signal, such as singer voice picked up by a microphone, and uses electrical components to make it strong enough to drive speakers. The sound wave keeps its original pattern, so the listener hears exactly the same sound, only louder. Key components, we have the input device, the one that receives sound signal. Example, microphone. Amplification circuit. This uses components like transistors or integrated circuits to increase the signal sound. Output device sends the amplified sound speakers or other equipment. Innovations in sound amplifiers, from vacuum tubes to transistors. Early amplifiers used vacuum tubes, which were bulky and fragile. The invention of the transistor in the mid 20th century allowed amplifiers to become smaller, more energy efficient, and more reliable. Digital signal processing. Modern amplifiers can process sound digitally, allowing for noise reduction, equalization, and sound effects. DSP technology ensures clearer sound even in noisy environments. Wireless amplification. Innovations in Bluetooth and Wi-Fi allow sound systems to work without cables. This is useful in power portable speakers, wireless microphones, and modern home entertainment systems. Number 4, integration with light technology. In large venues, Amplifiers are paired with LED lighting systems to create synchronized audio-visual experiences. In telecommunications, fiber optic cables carry light signals that can be converted into sound, requiring amplifiers to make the audio loud and clear. Applications in daily life. Public speaking, so microphones and amplifiers ensure that everyone in the room can hear the speaker. In concerts, powerful amplifiers combined with stage lights create immersive experiences. Hearing aids, miniature amplifiers help people with hearing loss. Television and cinema, amplifiers enhance sound quality for better entertainment. Connection to physics, sound waves. Amplifiers work by increasing the amplitude of sound waves while keeping the frequency the same. Light waves and in integrated system, light waves used in fiber optics or LED displays work alongside sound to deliver information to create experiences. The development of sound amplifiers reflects how technology can transform simple physical principles into powerful tools by combining innovations in electronics with light-based technologies. Today's amplifiers deliver clearer, more efficient, and more immersive sound experiences, whether in classroom, concerts, or communication systems. Sound amplifiers are devices that increase the amplitude of sound waves, making them louder without changing their pitch. They are found in everyday technologies, from mobile phones and televisions to large concert sound systems. Recent innovations in amplifiers are not just about making sound louder. They are also about improving clarity, reducing distortion, saving energy, and even integrating light for communication or visual effects. Number one, how sound amplifiers work at the basic level. There is an input signal, the weak audio signal from a microphone, instrument, or device. The amplification stage, electronic components like transistors or operational amplifiers increase the signal's voltage, current, or power. Output stage, the strongest signal is sent to speakers, producing loud sound. And the key principle there is that amplifiers modify amplitude, not frequency. The sound pitch stays the same. Types of sound amplifiers. We have analog amplifiers, which is the traditional designs using transistors or vacuum tubes, warm sound, and often used in music production. Digital amplifiers, the Class D, use digital signals are smaller, lighter, and more energy efficient. Hybrid amplifiers combine analog and digital features for both sound quality and efficiency. Key innovations in sound amplifiers. So we have smart amplifiers, automatically adjust volume and equalization based on room acoustics, protect speakers from damage by controlling peak outputs. Example, modern Bluetooth speakers that adapt to different environments. Letter B, energy-efficient amplifiers. Class D and Class G amplifiers use switching technology to reduce heat loss, important for portable devices and longer battery life. Wireless and compact designs. Amplifiers integrated into earbuds, hearing aids, and portable devices. Use of Bluetooth and Wi-Fi for audio transmission. Integration with light technology. Optical amplifiers in fiber optic communications boost light signals for long distance transmission without converting them to electrical signals. Laser-based projection systems combine audio amplification with light projection for presentation, concert, and multimedia shows. And letter E, AI-driven audio processing. Artificial intelligence can reduce background noise, enhance speech clarity, automatically adjust amplifications for different sound types, music, speech, effects. Number 4, application in society, education. Microphone amplifier systems in classroom help students hear clearly. Healthcare, hearing aids with adaptive amplification improves quality of life. Now, entertainment. Concerts, movie theaters, and gaming setups rely on precise amplification. Communication, sound amplification in teleconferencing and broadcasting. Public safety, megaphones, and PA systems for announcements. Connection between sound and light and communication. Fiber optic technology uses light to transmit information, but sound is often the original input. Voice calls or audio streams. Audiovisual synchronization ensures that amplified sound matches projected images or light effects. Laser microphones use light beams to detect sound vibrations from a distance. The physics behind it, sound waves, longitudinal mechanical waves that need a medium, light waves, transverse electromagnetic waves that can travel in a vacuum. And then amplification process increases the energy carried by the wave for sound, which means a larger pressure variations for light, for light, a higher intensity. Future trends, fully AI-controlled amplifier systems that customize sound for its listener. Nano amplifiers for wearable devices and medical implants. Quantum optical amplifiers for ultra-fast, secure communications. Integration of holographic light projection, surround sound. Innovations in sound amplifiers show how science and technology combine principles of sound and light to create better communication systems, entertainment experiences, and assistive devices. Understanding connect these concepts connects classroom physics to real-world applications, showing that wave properties are not just theories, but the foundation for technologies you use every day. So we will have a next part of this lesson. So as you see, the connection between the sound and light amplifiers. So there is a sound amplifier and then the light amplifier. Look at that. So see you in our second part or next part of this lesson 63.